This is our third video for analysis of variance. We're going to talk more about partitioning sums of squares. An objective here is we hope you will be able to partition sums of squares for a one-way analysis of variance into the total between and within group variance or sums of squares. So when we think about sums of squares, as we have previously in our last video, we know we're taking deviation scores, squaring them, and adding them up. If we do this for an entire data set, we can have the total sums of squares. Now we can break out total sums of squares into two other components, the between sums of squares and the within sums of squares. So we have this concept of sums of squares, which before we saw was take each value for y minus the mean, square it, and sum them all together. We can see that we have our first sums of squares for sums of squares total is equal to the sums of squares between plus the sums of squares within. We're going to go through and take a look at some of those subscripts and how we can calculate sums of squares total, sums of squares between, and sums of squares within. So the first component, the sums of squares total, is effectively each score minus what we're going to call the grand mean, or the mean, or the average of all of the averages. That second component is the mean of each group minus the grand mean. And that third sums of square component is the score minus the mean within each group. So let's take a simple data set. We have y, and we have three groups. Group 1, Group 2, Group 3. And in each of those groups, we have three pieces of data. So for example, Group 1 has the values of 1, 2, and 3. Group 2 has the values of 3, 5, and 7. And Group 3 has the value of 6, 8, 10. Each value of y, we consider y sub ij. That is, y sub I for the individual or the person, and j within each group. So person 1 in group 1 is y sub I sub 1, 1. So we can also represent our groups as distributions. You can think of the data that we just saw for groups 1, 2, and 3 as three different distributions. We could also pull all of the data into one group, and we could create, instead of a mean for each individual group, we could create the grand mean for overall groups. So we could take all our data, and we could add this together and get our grand mean. The distribution for that would look something like this. I got this out of SPSS. We can see that the grand mean, or the mean, for all of our scores, regardless of what group you're in, was 5, with a standard deviation of 3. We have 9 different people represented. So the grand mean, represented by y bar with 2 dots, equals 5. We could take and calculate out some deviation scores and create our sums of squares. So we could take our values for each person and see how far away they are from the grand mean. Remember, the values for each person are represented by y sub ij, and the grand mean is represented by y bar with 2 periods afterward. We can see that if we take y for each person, subtract the grand mean, we get sums of squares for each individual person. So, for example, for the first person, their value of 1 minus the grand mean gives you a difference of negative 4. Quantity squared equals 16. That would be y sub 1, 1. And for person number 4, they would be in group 2, so they would be y sub 1, 2. And their sums of squared value is 4. We take all of those values, we sum them up, so we sum across all persons, all those i's from I equals 1 to n. N is just the total number of people. And we sum across all of these groups. We have I equals 1 to 3. We have 3 different groups for j. J equals 3. We do that for each individual person. We sum down those rows. 16 plus 9 plus 4, etc. down through 25 equals 72. That is the sums of squares total. Now we have our 3 groups. We can see what the distribution of those 3 groups look like. Visually, plotting these 3 groups helps us understand some of the differences. We also have here the means and standard deviations for each group. The symbol we saw earlier for sums within the sums of squares, one of them, was the mean for each group, which is y bar dot j. So across, effectively, all people, what is the mean within each group? So for group 1, we could see that y bar dot 1 equals 2. Group 1's mean is 2. And group 2's mean equals 5. And group 3's mean equals 8. So now, as we did with the gram mean, now instead we can do the deviation scores and sums of squares between the person and their group mean. So we can take the person again, y sub ij, and the group mean, y bar dot j. We can do our calculation. This is the sums of squares of the individual and how far away they are from their own mean, their own group mean. So yij, and that's away from our group mean, which is y bar dot j, and we now have our sums of squares within each group. And I point you to the bottom of the screen here where we have the summation across i's, the summation across j's. So across all people within their groups, we're going to take the deviation of the person minus that group's mean, square that, and we get the sums of squares for within group sums of squares. But now we can use that data that we have previously. We know that group 1's mean was 2, group 2 mean was 5, and group 3 the mean was 8, and the overall mean, the gram mean, was equal to 5. So now we can see how far away means of a group are away from the gram mean. This is what we're doing when we do between groups sums of squares. And that's what we have set up here. We're going to look at the mean of each group and how far away it is from the gram mean. So group 1's mean was 2. It is 3 units away, -3 away from the gram mean. We square that, it's a positive value of 9. We do that for each group, and we can sum that value. So the mean for group minus the mean, the gram mean, and we now get the sums of squares for between groups. So just to recap, we've gone through and divided up the sums of squares total into sums of squares between and sums of squares within. So the sums of squares total ended up being 72. The sums of square between ended up being 54. And the sums of square within ended up being 18. We can take those values. You can see that the sums of square within, 18, plus sums of squares between, 54, and we get the value of 72.